It is now some time since the previous video when I changed the polarity of the leads in this multimeter from the copper wire that is in the saturated solution of copper sulfate and the porous wood connected to the common input of the voltmeter. Right, the reading now, as you can see, is positive about 300 millivolts, but it is reducing. Now, I find this very strange because copper in a saturated solution of copper sulfate is supposed to have a stable electromotive force. The relationship between the solution and the copper is supposed to be stable, so that we can use this as a stable potential against which we can measure a variable potential. But as you can see, it is not stable. When we switch on the meter, we can see that the potential of this copper in this saturated solution of copper sulfate is reducing. Now what I'm going to do is I'm going to switch the meter off again. I'm going to short out the meter and switch the meter back on again. Just a minute. To make sure that it is 0 on the meter. Right, there is now 0 on the meter. So, we now connect the meter, we switch the meter off, we connect it to the copper is the active, that's the positive side of the meter, and the wood is on the negative or common side of the meter, and I will switch the meter on again so that you can see the reading. It's 355, but it is reducing. Right, so I'm going to switch it off again, and I am going to now change the polarity of the leads into the meter. So the black lead from the wood is now in the active and the red lead from the copper is now in the common. Remember that the meter determines that whatever is in the common is the 0 for the purposes of this display. Now you notice that it is still showing positive, but this positive is reducing very quickly. It's reducing much quicker than it was when the red was in the active and the black was in the common. And if you notice now, it's approaching 0, and now there is a negative sign in front of the display reading. So in other words, this meter and the method that it's using to measure the potential difference between this and this is showing that the potentials are changing with time. It is now showing that the common is more positive than the other input. So the reading on the meter is negative. I think that this shows that there is some form of capacitance in the copper sulfate electrode itself. In other words, it is not a stable reference electrode. It is an electrode made of copper in a saturated solution of copper sulfate. This is not stable. You cannot make a measurement against this value. So much for your half cell, which I will explain in another video.